Hi, and welcome to question 8 of the Leaving Cert Ordinary Level 2024 Paper 2. So as always, if you want a copy of these notes, just send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. So question 8 is trigonometry, if I recall. This part A1 is worth 10 marks, and we'll read through it, but as I always suggest, pause and just give it a go yourself. Even see if there's anything about the triangle that makes sense to you. So a fish shop has a vertical sign outside its front door. In the diagram below, the sign is represented by FH, with FH is equal to 3 meters. So that heavy line there is what they're talking about. A cable is tied at the top of the sign and secured to a point G on the horizontal ground. So they're told us that this is horizontal and this is vertical. That creates a 90-degree angle, which is a hint. G is 1.4 meters away from H, as shown in the diagram, and it's not to scale. Now, part 1 says, and they're very direct here, use the theorem of Pythagoras to find the length of the cable GF. Give your answer in meters correct to 1 decimal place. We'll worry about that when we get to the end. Now, they've told you what to do, so we need to get and find Pythagoras' theorem. Now, Pythagoras' theorem is the length of the longest side squared is equal to the sum of the squares of the other two sides. Okay, so I've identified the longest side as being C. That's always the side across from the biggest angle, and that's the 90-degree angle. And something I suppose I've over time gotten to appreciate more and more. But one of the special things about triangles is that the bigger the angle, the longer the side. So the biggest angle has to be 90 in a right angle triangle. So the longest side has to be C. Now, it doesn't actually matter which you call A or B. I've just called 3 the A value and the 1.4 the B value. And that leads to my problem solving. I'm writing out the 3 pieces of information I have. Now, with any formula with 3 unknowns, if I know 2 of the 3 things, it is solvable. Okay, so I put my numbers in the right spot. Okay, and put them in brackets, even though I don't necessarily need to. It's kind of good practice, but it's especially important with negative numbers. And then I'm putting that through the calculator. So 3 squared plus 1.4 squared adds to give 10.96. Now that's not my answer. I have to remember that there's a square here. So I can get rid of that by square rooting. If I do something to one side of an equation, I have to do it to both, or I have to do it to everything on the other side. Then I put that to the calculator, and I got a value of 3.3, which is already at 1 decimal place. I made sure to include the units, which in this case are meters. So pretty straightforward, especially since they told you what formula to use. So you're just showing that you're able to use a formula and able to do it successfully. And a good 10 marks for that effort. Now, part 2, okay, which is a 5 marker, says show that the size of the angle FGH is equal to 65 degrees. Now, it's the number here, the G, that matters. So this is the angle they're talking about, FGH. You're trying to show that that's 65 degrees. Now, we know from the previous answer, you could have used 3.3. I used the unrounded figure of 3.31. It's still a right angle triangle, which brings us to the formulas for the trigonometric ratios. So the sine of an angle is equal to the opposite divided by the hypotenuse. So it's exploring that relationship. So for every angle in a triangle, we can relate the opposite side to the hypotenuse. These have all been written down, programmed into calculators, and we're just using that information to find a missing thing, assuming sine works, although in this case it's going to be tan. Now, the cosine of an angle relates the adjacent side to the hypotenuse. The tan of an angle relates the opposite to the adjacent. And that's all they are, just 3 different relationships that for whatever reason are called sine, cos, tan. And sometimes I say that like ratio 1, ratio 2, ratio 3, but, it's the same thing. Now, if I try use sine, okay, I'm trying to find the angle. I have the opposite, I have the hypotenuse, okay, because I found that in part 1. So sine would work, okay. Cosine, I have the adjacent, I have the hypotenuse, cosine would work. Or tan, I have the opposite given to me in the question, I have the adjacent, so that's the one I've chosen to go with. Okay, it doesn't actually matter because we already found the hypotenuse in part 1. Then I've written out my formula. I've written out the piece of information I have. I'm looking for the angle. I input my 3 instead of the opposite, my 1.4 instead of the adjacent. And then I want to find what the angle is. So I need to retrieve from the calculator the inverse tan of 3 over 1.4. Okay, put that to the calculator, making sure it's set to degrees. And then I got an answer of 64.98. I rounded that to the nearest degree. The 9 here is what matters. It rounds the next number up by 1 to get 65 degrees. I've proven it. Okay, so pretty straightforward, especially since you had the answer. If it's a right angle triangle, it's going to be either Pythagoras or the sine cos tan ratios. Okay, and they most likely would assess it in the exam. So try make sure that you're proficient in using those formulas, and at least you can go for the attempt or mid partial if things don't work out. But hopefully, you'll be successful. Now, part 3 says a second cable from G is tied to the sine at the point K. So it looks like halfway-ish up. Actually, I decided to say that, where K is halfway up the sine FH. Murade says that the size of the new angle KGH, so KGH, okay, so it'll be less than 65, is half the size of the angle FGH. Okay, so we know that FGH is 65. She's saying that it would be, 32 and a half. Okay. Now, is Murade correct? Okay, use calculations to support your answer, and we have a yes or no choice. Now, okay, I've picked no, and I'm going to see if it's correct by using tan. Okay, I know that this height here is 1.5 meters because they tell me that K is halfway. Okay, but it was 3 up as far as F. Half of 3 is 1.5. And I'm just dealing with a different triangle. I don't know the hypotenuse, although I could technically find it using Pythagoras' theorem. But I'm going to go with tan and the opposite in this situation. So this is the angle I'm trying to find. That's the opposite. That's the adjacent. That's the hypotenuse. Okay. So I've written out the information I have. I'm looking for the unknown, the angle. So just like the last one, the tan of an angle is if relates to the number 1.5 divided by 1.4, which I don't know what that is, but it's just, it's in a strange fractional form. It's still a number though, okay? I'm going to try find inverse tan of that number. Again, making sure my calculator is set to degrees. I found the answer is only 46.97, okay? I probably should have said it here. 65 is greater than 47, but I'm actually arguing for Murade's point that half of 65 is greater than 40 is what we're looking for. So 32.5 is less than 47. So it's not half. So Murade is wrong, okay, in her assessment. That's it. Now part B here, part 1 is worth 10 marks. It says the fish shop has a logo with some measurements as shown in the diagram below, and again, not to scale. This is a pretty complicated diagram, and I can see like a triangle here, a triangle here, and then a triangle with very little information here. They tell me that AB is equal to 12, so they give me that on the diagram. They tell me that AC is 10, so that's that length there. They tell me that the angle ABC, and it's always the middle letter that matters, so it's the angle at B, is equal to 37. All that is given to me on the diagram. I'm only really focused on this triangle here at the moment, and they say work out the size of the angle theta, where theta is the angle BCA, and they label that as well. Now, I don't particularly like the symbol theta. I don't mind it, but I appreciate that lots of people don't like it. It's not familiar. You can always in your head or write it down, just call that A. So you're trying to find this angle here. Whatever you call it, doesn't really matter. So I'm going to focus on that now. It's not a right angle triangle. So neither Pythagoras nor the sine cos tan ratios will work. Okay. We can't assume it's right angled, even though it kind of looks 90. Now, if it was 90 and we had 37, this would be a very easy question. So because we can't assume, we have to fall back on other formulas. And one of these that might work is the sine rule. I always try the sine rule first. If the sine rule doesn't work, it'll be the cosine rule. So with the sine rule, there's 4 unknowns, little a, big A, so the side and the corresponding angle, and you relate that to another side and its corresponding angle. Now I'm labeling this. This is I'm calling this. I'm kind of relabeling it. I'm calling that little a, and that's angle A. Even though there is a bit of confusion maybe in your head with the labeling here, I'm ignoring their labeling. I'm using it myself. And then I'm relating that to another side, an angle. I have the side here, I'm calling that B, and I'm calling this angle B. So this formula has 4 unknowns. I know 3 of the 4 things, leaving me with only 1 unknown, so this will work. Now I substitute in the numbers instead of the letters. Okay. Now it's a bit tricky. I have to try isolate my unknown. Okay. Now I do that. What did I do here? Well, actually, I've done a trick I actually learned off a student in the first few years of my teaching. I didn't think it was possible until I tested it, and I was like, oh, it's totally possible. You can invert both sides. Like it would be a mistake if I only inverted one fraction. If I invert both fractions, nothing's changed. Okay, and that's as long as you do the same thing to everything, nothing changes. Okay. Now I now need to get rid of the 12 because I want to isolate this at theta. So the 12 here is being divided on the left-hand side. When it moves across to the far side, it'll do the opposite operation. It'll multiply by everything on the far side. Now, this is just a number, but I'm not going to worry necessarily about converting that to a number yet. I can leave that as just one big block of things. It is a number. I'll worry about what that is later. Then I'm bringing sine across, and if you bring sine across the equal, it turns into its opposite, which is inverse sine of everything on the far side. This is programmable in the calculator, and I got a number 46.23, and that rounds up to the nearest degree, or rounds down rather, to 46 degrees. So this is 46 degrees. Now, arguably, I now can find out what the angle is up here if I'm asked, but that's the question finished. I can move on. Now, B part 2, okay, and we should note we do have some more information here. I didn't include it on this diagram. It says CF is equal to 22. Okay, that's this length here. It says EF is equal to 11.8, and they give that information on the diagram. And then they say EFC, so EFC is equal to 110 degrees. Then it says use the cosine rules that are being direct here. They're telling me what to do to work out the distance CE, which is this longest side here. Now I should know from one thing that the size of the angle relates to the length of a side. This is the biggest angle in this triangle. This should be the longest side. So my answer should be bigger than 22. Just small thing, but sometimes I call it the BS meter. Apologies for the rudeness, but if you have a good number sense, if you make a mistake, sometimes you can catch that mistake by using those little things that might seem intuitive to lots of people. So give your answer correct to one decimal place. So I'm going to write out the cosine rule. Okay. Now I'll worry about the labeling there in a second. So the cosine rule is this. It's in the maths tables. Make sure you copy it across well. Okay. And it reads a squared is equal to b squared plus c squared minus 2 times b times c times cos a. Now, cos a is just a number. Okay, we need to know what the angle is to know which number cos a is. I'm told that I'm told the angle. Okay, I'm trying to find the side opposite, and the cosine rule will work if I know the two sides either side of the angle I'm given. Okay. So the A is what I'm looking for. B is 22, C is 11.8, and the angle is 110. Now I substitute the numbers instead of the letters. Okay, and now I can program everything on the right-hand side into the calculator, making sure my calculator is set to degrees. And I got an answer here of something like 800.8169. Now, a big common error here is people forget that there's actually a squared here. And sometimes you can avoid those kind of errors by keeping writing what's on the left-hand side. Now, to get rid of that square, I'm going to square root the left-hand side. If I square root the left-hand side, I have to square root everything on the right-hand side. In this case, that's just the 800.81 whatever. Put that through the calculator. Now, the square root cancels the square on the A, and the square of 800 point whatever is equal to 28.2987, but the question asked me to leave that to one decimal place, so it's the 9 here that matters. 9 is greater than 5. It rounds the number prior to it or before it up by 1. I get 28.3. If there are units involved, always include the units, and the units in this case are centimeters. And that's it. Now then it says to me that CDEF is symmetrical around CE. Okay, so CDEF is symmetrical around that. So that we're talking about this shape here. It's not a square, okay? Work out the total area of CDEF. Give your answer correct to the nearest centimetre squared. Now I'll move on to the answer. Okay, so what they're telling me is because they're symmetrical, the area of CFE is equal to the area of CDE. So if I can find the area of this triangle, which I have a lot of information about, I can just double it to get the area of the full shape. Okay. Now, that's I'm just stating that in terms of words. So we're going to use the area formula for a non-right angle triangle. And there's 3 variations of this, but I always use the same one, and I just label the triangle based on what I have. So the area is equal to half times A times B times sine C. Now C is always the angle you have, so I'm going to call the 110 C, and then I need to know the sides either side of it, kind of like the cosine rule, okay? And then I can put that through the calculator and find out the answer. So I'm substituting the numbers instead of the right place, and it is always useful to write out what you have and don't have so you make less errors. Run that through the calculator. I got an answer of 121.9721, but they asked for that rounded to the nearest centimetre squared. The 9 here is what matters. It rounds the next number up by 1, and I got an answer of, actually I didn't bother doing that yet. Actually, I'll do that in a second. Because we only found the area of this one triangle, I'm doubling it by adding it on again. I could just multiply by 2, it's the same thing. So I end up with an answer of 243.99. It's still the 9 that matters. That rounds up the number before it to 244, and I include the units, even though they have them in the question. It's always something you should do. And I get 244 centimeters squared. Right, that's the end of question 8. Okay, as always, if you want a copy of these notes, fire me off an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.